Good morning, students. Okay, we'll continue our lecture with modulators. Modulators. So, we have already seen a few modulators. One is scalar modulator. We're done with this, right? Also, we have seen product modulator. Modulator. The diagram for the scalar modulator, I will redraw this just for your reference so that you will get refresh your memories about the same. Okay, so this will be nonlinear device. This is your nonlinear device. This will be your filter. That means capacitor and inductor, they will be in parallel. Then you have two voltages. One will be your M of t, another one will be your sinusoidal. This will give you the carrier AC cos of omega ct, right? So this value will go to this one, and this will be total V1 of t. Similarly, after the output of here, this will be your V2t. Non-linear device. Can anybody give me some example of non-linear device? Obviously, this will be a scalar device. I have already given you some examples. Can anybody give me example?
Diode.
Well done. Diode. We have seen how this will act as a scalar device. Scalar device. From its characteristics, we're done with that, right? Ultimately, you have this. This is a transformer. This is C capacitor, and this is transformer. Obviously, this is an inductor here. Okay, so output is connected to your RL, a resistor, pure resistor network. Resistive network is used. So this is another diagram for your scalar modulator. Same phenomena happens here, whatever I have explained to you. Okay. Now product modulator, we're done with that. So product modulator diagram, before going for the switching modulator, that I will explain in detail. Just draw the diagram this product modulator once again, just to brush the things. So you have your baseband signal. This is your M of t. Baseband signal is also called a modulating signal, right? Or message signal. This goes to the product modulator. Then output, because this will be C of t also, and output will be equal to X of t or M of t into cos of omega ct, because you can treat this as one amplitude, maximum amplitude, let it be one. This is cos 2s by fct, that's omega ct, right? And this will be your signal, and this will be your double sideband suppressed carrier signal, modulator signal, obviously, that will be ready for the transmission. If this will be a wireless transmission, then you will use an antenna, right? Anybody having any confusion till now?
No, sir.
Yeah, we're done with this already. I'm just brushing up. Thanks. Okay. Now, today we will start with another modulator, pretty important, that is switching modulator. And this is nothing but a device for the generation of AM waves. These are all devices for the generation of AM waves. You can see this is device for the generation of AM waves. Okay, amplitude modulated wave. Before explaining the working of a switching modulator, I will just draw the diagram for the same. So this is the circuit diagram for the switching modulator. Circuit diagram for your switching modulator. Okay, this one. So you have one voltage here. Obviously, this is an this voltage source. You can say that here is an oscillator which we call cos of omega ct, and this is your another voltage source. You can say that this be m of t. You can consider this as x of t, b of t, whatever you can. So this is your baseband signal, message signal, and this will be the carrier signal that generated from here. And then you require some, because switching modulator we are using the diode here. So this is diode, and obviously this is non-linear device, right? Non-linear device. Got it?
Yes, sir.
Okay. Linear and non-linear device, how can you conclude? You can conclude this from the superposition principle and homogeneity principle. If it does not follow the homogeneity and superposition principle, then you can say this is a non-linear device. That means current will not pass in both directions. The current will pass only from this to this P to N. It will not pass from N to P. Of this, there will be some current that will be in microamperes, and that will be pretty negligible. You can neglect that. That means in reverse bias, whenever you do the reverse bias for the diode, there will be no current. But in case of forward biasing, current will flow. In ideal case, you can see this will act as a short circuit in forward biasing, and this will act as an open circuit in reverse biasing. So that is what you have to remember here. Okay, then ultimately this will be connected to your resistor. This will be connected to your resistor. So first value you have, that's V1 of T. You must remember this. So this value will be your V1 of T. Similarly, this value here will be V2 of T. That means because they are parallel voltages, and this V2 of T also, right? Because parallel voltages are same. In parallel voltage same because both are V2 of T. So this is V2 of T and this V2 of T. So output here is V2T, right?
Yes, sir.
Yes, sir.
Okay, okay. So we will write, can anybody tell me what will be the value of V1 of T? First of all, we will try to find the value of V1 of T. You can consider, let this be positive, let this be negative, and tell me what will be V1 of T. Anybody?
Sir, M of T and cos of T.
Yeah, but plus, because these are
Okay.
voltage sources, they will be added. Okay, so well done. So it will be M of T plus AC, whatever you have written here, AC cos of omega CT. So this is the value of V1 of T, and that you can put this as equal to equation 1. This is your equation first. And it's assumed always, it's assumed because for the modulation sake, we have modulation index, that's ME or mu equal to AM by AC. For this to modulate properly, that means it should be under modulated, that mu value should be less than 1, which implies AM divided by AC should be less than 1. That means AM should be less than AC. That we will use here because it should be under modulated, it should not be over modulated, then there will be problem. You cannot, there will not be direction, will not be proper, there will be some interference, and ultimately distorted signal will be received and you will not get the proper information which was transmitted original. So you can say it's assumed, you assume this assumption, and that should be the case. It's assumed here that mod of mt means whatever you have your signal, modulated signal, that means its amplitude. Mod of mt, if you, somebody will tell you AC cos of omega ct, what will be its maximum value? Maximum value will be obviously 1, because cos range from 1 to 0, and this will be 1 value maximum. What about this? This value will be, so it will be equal to AC, maximum value of AC. That's maybe some positive value of AC, whatever you take, amplitude. So assumed here that maximum mod of m of t should be always less than, it should be always less than AC, because AC is the maximum amplitude in case of carrier. It should be always less than compared to AC, right?
Yes,
Then
sir.
then what will happen? Because ultimately you need V2 of T. Then what will happen to V2 of T? Can anybody guess V2 value will be what? Because ultimately this diode may be, there will be two situations. One, this diode will be forward biased. That means this will be positive here and this will be negative here. This more voltage will be here compared to this end of diode. Or this will be negative, reverse bias. This will be negative of the supply and this will be positive. What will happen if this will be forward biased? And what will happen if this will be reverse biased? And accordingly, you will get the value V2T. Now tell me the values. V2 of T will be equal to, if this will be forward biased, can I draw the diagram like this? Let this be V1 of T, V1 of T. If this is forward biased, can I say this is nothing but your short circuit? This is just short circuit, because ideally I am considering this an ideal diode, not a practical diode. This is forward bias, that means this was positive, negative. This is reverse bias, short circuit. Whatever V1 of 2 you have here, you will get the same V2 of T here.
Yes,
Whatever
sir.
V1, right? So in this case, first situation when V1 is, this diode is forward bias, V2 of T will be equal to V1 of T.
Even
And V1 of T, in this case, obviously CT should be greater than 0. That means this situation is your forward. Are you noting down or not?
yes, sir.
This situation is forward bias. I'm trying to explain minutely. This is diode. That means forward bias, ideal diode you consider. Ideal, ideal diode, that means has zero impedance, zero impedance. So in this case, you will say that V2T will be equal to V1T. What about the another situation when the diode will be reverse biased? When the diode will be reverse biased, what will happen in that case? When diode will be reverse biased, I will draw the diagram for the same. Please tell me. Okay, please try to concentrate and tell me the answer. So this is your V1 of T. This is your reverse bias of the diode. This is acting as an open circuit. And this is your resistance. That means R, your load, and this is your V2 of T. Can anybody tell me what will be the value of V2 of T here? we can say that V2 of t will be equal to 0 because Ct, when this will be reverse biased, when your Ct value will be less than 0, when your Ct value will be less than 0, and it was forward biased when Ct value means amplitude value of this will be greater than 0. You have to remember that. So in this case, reverse biased diode, it will be acting as open circuit. So V2t will be ultimately equal to 0. So in this case, you can say that diode shows infinite impedance. Diode shows infinite impedance. And ultimately, you will not get any signal, infinite impedance. That means you will get V2 will be equal to, I can say that it will be equal to V1 of t, and V1 of t is itself equal to mt plus Ct when Ct value is greater than 0, and this is equal to 0. This is equal to 0 when Ct is less than 0. You can say like this. This is the value, right?
Yes, sir.
Anybody having any confusion or question, please tell me.
No, sir.
Okay, good. So this is another modulator how to generate the AM signal, right? Another one will be your balanced modulator. And balanced modulator is used for double sideband suppressed carrier. So we have another modulator that is balanced modulator. This is your homework. You just do this. First point, differentiate between. Tomorrow I will see this, okay? Please don't attend my class if you will not do this. Differentiate between double sideband full carrier and double sideband suppressed carrier. Differentiate when I mean just draw the comparison and write everything that's needed for this and this. Everything means mu value should be equal to power value and all these equations you just write down. And maybe this question may come in your exam, maybe, I don't know. But you just try to do all these things. So balanced modulator, I will just draw the diagram and this tomorrow we will study this in detail. So you have one AM modulator here. Then this is M of t is directly beyond this. Similarly, you have here another AM modulator. You can draw with me. AM modulator here. Okay, so this will be your minus M of t. Minus means this is reversal in amplitude. You are reversing the amplitude here. M of t and minus M of t. What's the difference? You are reversing the amplitude. Suppose this is your signal M of t. M of t and this is t. If somebody will tell you what will be the graph of minus M of t, you will just reverse the graph. Positive will be turned to negative, negative will be turned to positive. And this is your M of t. So this is your M of t and this will be your minus M of t. Are you getting me or not?
Yes, sir.
Okay, so this is the difference between these two. Okay, I will try to draw the diagram again. Okay, so ultimately what you will get then, this is oscillator here. Oscillator will generate the signal. Obviously, oscillator will generate your carrier signal. That will be your AC cos of omega CT. And ultimately, because this is a modulator means product modulator, then you will get S1 of t here. We will see what will this value. Similarly, you will get here S2 of t. and finally they are added up. You're using the summer, and summer will do, you're adding here these two, this will be plus and this will be minus, minus 1, and this is s of t. This is s of t value. So ultimately what you will get, so we will just try to write s1 value and s2 value. What we will get s1 value, because am modulator equation, in case of am modulator, everybody knows that this equal to ac, because this is oscillator, here you will get ac cos of omega ct, and this here also, this is ac cos of omega ct. This is s1 of t is ac 1 plus aa m of t into cos of omega ct. Similarly, S2t, because here message signal is negative, then what you will do here, this is 1 negative into this, you will get minus Ka mt cos of omega ct, right? And finally,
Yes.
you are just adding these two terms. We'll study in this in detail tomorrow, but you just write down the equation S1 of t, then minus S2 of t, because S1 is added positive and S2 is negative. And adding these two, finally you will get twice Ka AC cos of omega ct into m of t. And this is your generation. Since this is message signal and carrier, they are multiplied with each other, this is the generation of double sideband suppressed carrier. This is also a generation of double sideband suppressed carrier, right?
Yes, sir.
Okay, so
Yes,
these
sir.
are the some of the modulation methods by using this. Usually we're using the for the generation of double sideband suppressed carrier, we're using the bounced modulator and ring modulator that used for the same. And there is certain advantage, few advantages of double sideband suppressed carrier compared to your double sideband full carrier. You have to study tomorrow. Okay, anybody having any question or confusion or any query? Please,
No,
we can wind up.